Welcome to another video. In this video we are going to solve this question, which is section B, question number 10, part B from BHSEC 2022 mathematics paper. Okay, so the question says if A equals to this matrix, then first we have to find A inverse. Then we have to use this A inverse to solve this system of linear equations. The first and foremost thing that you have to understand is that if we use matrix to find the solutions to the system of linear equations, then we are using the Merton's rule. So the Merton's rule have to use inverse of this coefficient matrix, okay, to find the value of x1, x2 and x3, okay. So this is very important, and if you see very carefully, this matrix is coefficients of these system of linear equations, okay. Therefore this is the coefficient matrix, okay. First we have to find the A inverse. Now to find the A inverse, we have that A inverse equals to 1 divided by determinant of this matrix A times adjoint of the matrix A, okay, this matrix. Therefore first we have to find the determinant. So we can say determinant of A equals to this matrix. So you have to change it to the determinant sign, okay, because you are finding the determinant. Now to make our life easier, what I will say is I will make this entry 0, okay, so that I can expand through C1 and get the determinant easily. So to make this two entries 0, what I will do is I will say R1 equals to 4 of R3 and add it to R1. Then I will say R2 equals to negative 3 of R3 and add it to R2. Then these two entries will become 0, right? So now I will get 0. So 4 times negative 3 is negative 12 plus 2 is negative 10. 4 times 2 is 8 minus 9 is negative 1. Then negative 3 times 1 is, this one is 0. Then negative 3 times negative 3 is 9 plus 4 is positive 13. Negative 3 times 2 is negative 6 plus 1 is negative 5. Then here 1, 3, 2. Okay, now I will expand through C1 easily to get the determinant. So I will say expanding through C1. Here this and this will get deleted, so it will get 1 times 10 times 5 is 50, right? So it is positive, negative is positive, 50. Then 13 times 1, negative 13, but we have negative in the determinant sign, so we will get plus 13. So our determinant will be positive 63, okay. Now next is to find adjoint A, adjoint of this matrix. So what is adjoint of matrix A? Actually adjoint of matrix A is transpose of the cofactor matrix. So if you find the cofactors of the matrix, then it will take very long time and it will run off our space also. Therefore we can find the adjoint of matrix A by the shortcut, but it employs all the steps involved in finding the adjoint A, okay. Therefore look very carefully. I will compute adjoint of matrix A. First what we will do is we will write this matrix. So we will have negative 4 to negative 9, okay. Then I will repeat these two columns again, so I will get negative 4, 2 like that, and it will repeat this all, so I will get 3. Then I will repeat these two rows down here again, so I will get, so this is our modified matrix. Now what I will do is I will cancel this first row and this first column, okay, and then I will compute for the minors. But when I compute and go down this word, then in the adjoint matrix I have to write this side, because as I've already said that adjoint is the transpose of the cofactor matrix, right? Therefore we have to follow this step, and then if you follow this step, then it will already be transposed and we'll get directly our adjoint matrix, okay. Now let's calculate this. We have here 4 times 2 is positive 8 plus 1 times 3 is 3, so it will be 11. Here 3 times 9 is positive 27 minus 4 is positive 23. 2 plus positive 36, so it will get positive 38. Here 1 times 1 is 1, minus of 2 times 3 is 6, so it will get negative of 5. Here we have negative 16 minus 6, so it will get negative 22. So this is our adjoint A. Okay, so when you do this, you have to be very careful not to make mistake of the signs and the arithmetic calculations. Okay, if you make mistake, then you won't get the value of x1, x2 and x3 at last. So our inverse of the matrix is just 1 by 63 of this matrix. Okay, so we will get 11, 23, 38, negative 5, 1, negative 23, negative 13, negative 10 and negative 22. Okay, so which will be just 11 by 63. So this is our inverse matrix. Okay, inverse of matrix A. We have to solve this equation by using the inverse of this matrix. From Merton's rule, we have that if X is the variable matrix and A inverse is the inverse of the coefficient matrix, okay, then we have that X, this matrix, is just the A inverse times the product matrix, and this product matrix is the matrix formed by these three numbers, okay, which is 2, 5 and 8. Therefore we have that x1, x2, x3 should be equals to this inverse, which is 1 over 63. I will write like this, 11. So this is our inverse of A times this matrix 2, 5 and 8. 2, 5 and 8. Okay, so when I multiply and then divide with this scalar, I will get x1, x2 and x3 value respectively. So I will get now x1, x2 and x3 as here 1 over 63, and here it is 11 times 2 is 22, plus 23 times 5 is 115, plus 38 times 2 is 304. Then here I have minus 50 minus 22 times 8 is 16, 8 to 16, 17, 176. Now I will get x1, x2 and x3 as 1 over 63, 441, negative 252, okay, and you will get x1, x2 and x3 as, therefore x1 equals to positive 7, x2 equals to negative 3 and x3 equals to negative 4. Now the last one is to verify whether these values satisfy all the equations or not. Okay, so we have that negative 4x1. Now I have written all these equations and let's check whether it satisfies all these or not. Okay, so we have that 7 times 4 is negative 28, minus 2 times 3 is 6, minus plus 9 times 4 is 36, which all should be equals to 2. Negative 34 plus 36 equals to 2, so we'll get 2 equals to 2. So it satisfies the equation number 1. Now number 2, we have 37 is 21, minus 43 is 12, minus 4 equals to 5. Okay, so we have, so this one is 5 equals to 5, so it satisfies the second equation. Now third equation, we have 7 plus 3 times 3 is 9, then minus 2 times negative 4 is negative 8, should be equals to 8. Okay, so we have 9 plus 7 is 16, minus 8 equals to 8, so 8 equals to 8. Therefore, by the value of x1 equals to 7, x2 equals to negative 3 and x3 equals to negative 4, it satisfies all three equations. Therefore, these are the solutions to the linear system. Okay, now we have found the inverse of the matrix A, the adjoint of the matrix A, and even solved the system of linear equations. I hope you all would have enjoyed this video, and I will see you next video when I solve more questions. Thanks for watching. Bye.